You guys can totally be heard. That's it. It's not going on. Can you guys hear me? I'm talking to the students. I think I've been broadcasting for 5 minutes. It never tells me to go live. It just automatically goes on. It's a new YouTube. Can you hear me? Yep, they're hearing all this. I'm glad. I hope I didn't swear or anything. Okay. So sorry I'm late. Technical difficulties, and also I got a message from the dean that I had to answer. And it turns out that the dean, his office is aware that there are students who are intending on cheating on the final exam. And we don't know who they are. But because of those students, I have to change the procedures of the final exam. I am now going to require the camera be used. So if you don't have a camera or a computer with a camera, you're going to have to get a webcam. And you're also going to have to show your student ID at the beginning of the exam. Unfortunately, just a few people can ruin it for everybody. And we have to take this measure to make sure that there's integrity and that it's fair for everybody, okay? So that is the plan. I will write it in an email as well. So make sure you have a camera and you know how to set it up so that it's on you while you write the exam, and that it actually videotapes you. Okay? It'll still be open book. I'm fine. You know, it can still be open book, but I have to make sure Using the camera, I mean, the camera with lockdown browser means your computer will be locked, but you can use all your documents. And people can have their phones and other computers, I guess. Muskan's asking for sample exams. All the questions I've given you are from exams. Okay, they're all old exam questions. So you're studying for the exam right now. Okay, you've been studying all along. So additional questions, I think you have quite a few to get through. If you really need additional questions, let me know. Yes, Nicole, you can use another device with Excel. I'm fine with using Excel. I have no problem with that. I'm not sure what NVM means, Nicole. I have to set up the exam, but I'm supposed to make it so you can't go back. Yeah, you're not able to go back, and they are randomized questions. I'm not so concerned about you using open book, because really, even in professional arena, people look at books. Doctors look at books. They Google it. People look at the resources. Okay. The problem is that it needs to be you looking for the resources, not somebody else. Okay. I need to be testing you. All right. So I'll send an email with the instructions of how it's going to go. But essentially, you're going to have a camera recording you through UMLearn, and that is on your end. You're going to make sure that you have a good connection and that it is. And that it's working. No, Muskan, you cannot go back to the previous questions. Okay, it's only one direction. Okay, so there's 30 of you here. For the people still coming in, I'll mention it again at the end of the class. So since we lost 40 minutes, I guess I have to tag on at least a half an hour at the end. People have to leave. I understand you can go, but then come back and watch the videos. I sent you the solutions to test 2, and there was certainly a lot of feedback. Students didn't like the way it was graded. There are some things that I was prepared to consider. So the grader is going to take into account that you weren't asked to identify sunk costs, so that shouldn't be a point. So everyone's going to get it. Actually, I think we agreed. I have to look at my emails. I think we agreed to just make the exam out of 1 less point, so you don't lose anything for that question. And then there's some other questions. So some people emailed me. I haven't gotten back to them yet. I'm just preparing to leave on my trip. So I'm going to look at those probably in transit on Saturday or maybe tomorrow. Okay, and so the TA will be available to mark. Saturday, we have to prepare for Saturday's test, so I still need to get to the material for Saturday's test. One moment, I'll be right back. So Hannah is asking me, okay, wait, Nicole asked, do we still have to get at least 50% on the exam? You have to get 50% on the exam, but like relatively speaking, Nicole, that's right. So it will be curved in a way. So 50% relative. No, that won't work. That won't work because then half the people fail. That doesn't even make any sense. You have to get 50% on the final exam. That's what I put in the syllabus. But let's see how it goes if I have to change that. You guys are so worried about the final exam. It's only worth 35%, and you will have 65% of the grade. The last test, the average was about 70%, more than 70%, and that's really good. I know some of you are really frustrated because you did think it was easy and you did think you had perfect marks, but there were oversights. There's some things you didn't get them you didn't get them, you didn't get full marks because there was some misunderstanding. Now, whether you should get 1 out of 5 or 2.5 out of 5 is an issue, and I can look at that. Okay, so I'll look at that on the weekend for test 2. As far as getting part marks for the final exam, I haven't made it yet, but I've seen how it is set up, and I have to set it up for you. I still have time for that. And there's multiple choice questions, there's fill in the blank questions. They are randomized, so not either by question for testing certain concept, or they're randomized with numbers in the same question. Okay, so that could be in multiple choice or fill in the blanks. And then there are some qualitative questions. Did I already write you this? There's some qualitative questions. Oh, I wrote one student. One student had asked me. And the qualitative questions, you have to express yourself in a couple of questions. Just 2. So total, I think there'll be 30 something, like 30 to 35 questions in 3 hours. All right? Obviously some are easier than others. So in one question I can't test too many concepts because I can't allow for carry-through error, because you're just going to give me a final answer, and that's frustrating, right? So there will be more like the questions you're trying or attempting in the Pearson MyLab Finance. All right, so we can talk more about the final exam. 6:45. Let's get started where we left off. Could you guys tell me? I didn't get a chance to ask the TA. I did communicate with him, but I didn't ask him how far he got. Did he look at the review exercises then that I shared? Harper, no, you can't go back and forth. You have to just go forward on the exam. Yeah, Muskan, so the final exam shouldn't be that hard, right? If I'm expecting you to get 50%, I can't expect much, right? Right? Think about it like that. Okay, you only did review 1. Okay, that's good. That's a lot. Okay, so let's continue. And then you have all those exercises with problems. So the exam on Saturday will be problems like the ones I've given you. So let's make sure you understand how to do them. Okay, thank you everyone. Review 1 is what you did with him. And I know there's like 4 other ones. Now don't be intimidated. It's like you have all the questions to the test. You just have to review them. All right. I apologize again for starting late. Okay, so let's see. Where did we leave off? So I did some really heavy stuff that I don't know if you had a chance to see. The only thing I didn't do yet is put the timestamps in the videos. I salvaged the videos. The last 2 videos I made got cut off at 2 hours for some reason by YouTube. So I'm thinking what I can do, maybe at 2 hours we'll take a break. So at 8:30 I'll take a break and I'll start a second stream. I'll call it part 1 and part 2. I don't know if it's because of the time that they're cutting it off or because we got interrupted that I got cut off. So I think that's how I'll do the rest of the stream. So consider this August 6th, part 1. And we'll take a break and then we'll come back with part 2. It'll be 2-hour videos. The final exam is cumulative. It's on everything, Faisan. So yes, things that we discuss will be on the final exam. Right, Komal Preet, yeah. There's going to be a little bit of everything. I have to make the exam. Basically, I know I've seen it, and I'm going to work with what the template that I have and adjust it, okay, for this class with the conditions that I've set that you have to pass it. But yeah, I can't make it relative because then half of you would fail. That makes no sense. I have to make it passable. All right. So what did we say last class? We left off with this discussion about variation. Okay, so the diversification and risk. So the idea is we're combining 2 securities, and the ones that I gave you were selected in such a way that they were negatively correlated. I wanted you to confirm this number on your own. So I asked you to, for homework, confirm this calculation, okay? You're going to need it for Saturday. Now, I noticed in the revision of the course schedule, basically I only had one thing in the last week. So I just moved forward a bunch of the chapters to the last week. I didn't know how long I was going to take on things, but I think it's going to be fine. It's going to fit for next week. We have 8 hours, and I can get through that material that remains. We're going to do options on Tuesday, and then we're going to focus on M&M theory, M&M propositions, and debt on Thursday. And then I left chapter 30 for self-study. The other thing that I did that I wanted to mention was, I can't remember now. Yes, Nicole, I'll make it passable. Let me see, what did I say to you? I'm just going to check my mail to you. Give me a second. Yeah, I changed the timing of the deadlines, and so you have time to do things. There was something I wanted to say, but it slips my mind. So anyway, if it comes to me, if I haven't said it, I will mention it by the end of the class. Okay. Okay, so I gave you this formula, and I said that when you see that, something like that, it just means take two variables at a time and calculate the covariation, multiply by the weights, right, the relative proportions in the portfolio that they represent. And then this just gives you, this is a way mathematically of writing out the procedure that we did with the matrix. Okay, so that if we can consider more than two assets, but we did look at just two, and with two securities we found that individually, if we were to weigh the variation, like holding these two securities separately, their variance, so if we weighed, so this is like a weighted average of the two variances of the two securities. It's much higher and more risky than holding them together in a portfolio. Okay? Much lower variance and standard deviation as a result. So it means that by combining assets A and B into a portfolio, we do eliminate some risk given the covariance term. We can, right? Depending on your diversification strategy, you're going to pick securities that perform negatively, like they're negatively correlated in performance. And diversification is a strategy designed to reduce risk by spreading the portfolio across many investments. So this kind of risk is different than the other kind of risk I'm going to mention, market risk. So we refer to the risk that you can diversify away by combining securities as unsystematic risk or unique asset-specific risks. So that's particular to the character of the asset, that it has that negative correlation with another asset. Market risk, however, cannot be diversified away. Now, what am I talking about? So this is the exercise. So the question arises, well, why don't we just combine a bunch of securities then? Does it really matter which ones? Do we have to make sure they're negatively correlated? Like, how should we go about combining them? Should we have a systematic approach? And so financial economists took up this question and with the notion that, well, let's find out. Let's do some empirical analysis of this question. So they got information on stock returns, and several different securities were considered. And they said, well, let's do this in a way that we're looking at the average of random selections. So they said, let's just go in, and they could do this. This is 1977, so computers could be used for doing this at that time. And you could, not everybody had a personal computer at the time, but economists did. So randomly they could select one security and compute the standard deviation of the security. So they did that many times. So they went in and randomly selected one, and then they calculated the standard deviation. Then they randomly selected another one, can calculate the standard deviation. So they took the standard deviation calculation. So you can imagine they had all that information available, like in an Excel spreadsheet type format. And then they took the average of all those standard deviations. The average of all those standard deviations of all the securities that they put in their analysis had an average of 49.2%. It's quite high average. So this was a study. This was the average of many random selections of one security. But then they said, okay, let's now combine them in a portfolio. So let's take two at a time. So they went two at a time. So let's say two was here. And they took two at a time, randomly selected them, calculated the joint standard deviation, right? Like they get the variance like we did at the end of last class, and then take the square root. And they did that for several pairs of securities. And then took the average of those. And that was a little bit smaller. You see? Then they went and took 2 and 3 and 4. So then they took 10 securities. So they randomly selected 10. And they combined them and calculated the variance like we did at the end of the class, or like I showed you, you could do at the end of class last week, or sorry, on Tuesday. Calculated for 10 randomly chosen at a time standard deviations, and then averaged all of those different sample results. And they got even lower, 23.9. And so on. So it was going lower. They found that the more securities you included, randomly selected, on average, you are reducing the risk. But to a point. It hits a threshold, or it hits a, there's a point after which you can no longer, just by selecting securities, reduce the risk. Okay? So there's this. So what do we do about this? So you got my point. So they found that it stops doing this, and the one thing to tell you is when does it seem to stop? Remember, this is on average of many samples drawn. Around 25 or so, according to this study. There have been other studies done similar to this, different kind of methodology, but similar result, that at some point it doesn't matter. If you randomly select on average, you still cannot reduce your standard deviation less than 19%. Okay, for your portfolio. But you notice in our exercise that we did just with 2, I showed you an example where we got a really low standard deviation. Right? We got down to, what did we get? Oh, I have to go here. we got a variance of 0.00015, which represents a standard deviation we got of 1.22%. It's much lower. So what does matter? What would succeed in getting us, you know, a lower standard deviation for our portfolio, a lower measure of risk? We refer to this that cannot be diversified or away, this non-diversifiable risk, as systematic risk. Okay, systematic risk is, another word for it is market risk. So it turns out that the total risk is the market risk plus the diversifiable risk. Okay? Now, in theory, we assume that diversification is costless. By adding more securities, you don't pay more, in other words. Okay, we're going to say, but that's not exactly, you know, managing a portfolio has transaction costs associated with it. Having a managed portfolio, a managed investment, like a mutual fund. That's why it's really advisable to invest. Often it's advisable to invest in an index that's not managed, that's just index representing something like a market portfolio made up of securities, or that tracks an index that represents the performance of the risky assets. So like the market portfolios like the ones that we've talked about, S&P, the TSX, in the States, Dow Jones Industrial Average. So anyway, we assume that diversification is costless, thus diversifiable non-systematic risk is irrelevant. Investors should only care about systematic market risk. Okay, so the point is, you can put together securities. Anybody could do that. You can even do it randomly and put many together, as many as 25, and you'll do the best you can at reducing your standard deviation, your measure of risk of your portfolio. But to deal with the market risk, you have to think about the effect or the relationship between the market risk as you consider the sensitivity of your security to market changes. Okay, so this is going to look familiar. Here's my example. Again, discrete information, just two states of the world, and I made them equally likely. So these are equally likely outcomes. You could have, so usually I would have like a P here, right? But I'm not going to do that. I'm going to say they're equally likely. And if there's a good state of the economy, the S&P 500 reflects that. So the returns on an index of a composite index of market of securities would be about 18%, but Bell Canada Enterprise stock returns would be 26%, much better. However, if there's poor performance of the index, the market index, 6% return, BCE does even worse. Okay, so it looks like BCE is very sensitive, and this will be picked up in a statistic like the beta. Now, what's the beta again? What's the beta? What am I getting? Beta is the slope. Okay, so if you have just two values, you could actually calculate the slope, change in y over change in x. Ugh. Okay. So what does it mean? If you calculate it, you actually get, so this is just plotting them, and here's 1, 18. So remember, when I introduced, or we reviewed statistics, and I mentioned using financial data, we always put the market returns here, and we always put the asset here. So market always on the X horizontal axis and the asset on the vertical y-axis. So we have 18 and 26. That's the top point, right? So that's one observation. Keep missing. Anyway, it's there. And then you have the 6 and minus 4 over here. So they can make a line, actually. Just because you have two observations, you can actually see a line. And it's the slope of the line that is the beta. It measures, it captures in financial, with financial data, it captures the sensitivity. Since I can interpret the beta, if you calculate it here, it's going to be positive 2.5, and the interpretation is, you can think of it like divided by 1, and you say for a 1 unit increase in the X, so we're saying 1%, because these are in percentages, that's units, right? So 1% increase in the market return, BCE returns 2.5. So that's quite dramatic. It's more than the market. Similarly, if the market return is negative, so a negative 1%, then it's going to be negative 2.5% change in BCE. Okay, so it's very sensitive in both directions, positive and negative, of course. And the slope, remembering our formula that I asked you to review, the slope, so beta, right, is equal to, so this was just because there were two observations or two data points. That's why I could just make this line and interpret the beta in a simple way. But if I have a lot of data, beta is the correlation times, sigma y over sigma x. Remember that formula. Where does that come from again? That is from stats, where you learn B is R sy, and you should have learned, over Sx. Okay, but I'm using the betas because I'm giving you a representation of the distribution, and we like to use Greek letters for that. So Let's talk about that. I want to say if the correlation is positive, the slope is positive, right? What's the correlation? What's the formula for correlation? Correlation is equal to, remember, covariance I like this thick pen. It's the covariance XY standardized. SX, SY. Remember that. So it's just a standardized, it's an index representing the correlation or covariance between the two variables. So if the covariance is negative, the slope is negative. The correlation is negative, the slope is negative. I'm just saying the same thing. And similarly here, if this correlation, Greek letters, is negative, the beta is negative. Okay, so this captures the influence of the market on the asset returns. And even the way that we draw it, right? The fact that we put the market here as the independent variable influencing the asset tips you off that we've done it in a particular way to intuit or to indicate a certain thing. There is a relationship where market returns influence the asset, and we pick that up, we measure that, we capture that in this statistic. So this is what we're going to talk about right now. So the formula. So you should have spent some time with Excel or reviewing those, making those calculations that I made, confirming you can make them with the ex post ex ante pages or documents. Okay. So when I show these formula, you shouldn't be so intimidated. These are formulas that go in your formula sheet. I'm not going to be able to see your formula sheet. You might have many sheets, and that's fine because we are going to do this open book. Let's see. And I'm going to have to see if, the camera's going to have to show that it's just you writing the exam. All right, so this is the formula I just showed you. But that formula is just one way. Let me just point out the subscripts. I for asset, right? Remember, I always put M here, market, and I here for the asset. So that's always going to be like your, so M is like X and I is like Y, you see? So these subscripts here, this is SX over SY. And this is the R. The R of what? The correlation of the asset with the market portfolio or the market returns. Como-Appris, don't worry too much about it. You're going to do your best. I'm going to make sure that it's a doable exam, okay? Don't worry too much. Just study. All right. I just didn't want to make the whole course using the camera. That's the end. Muskan is asking, what's R again? So let's just write it like this, BRSY over SX, where R is the correlation. I can't put it in there. It captures the trend. When one asset or one security does well, what does the other do? The R tells you the direction and strength of the linear relationship. Only the linear relationship. Direction and strength of linear relationship. Okay, it's very messy. Okay, so that's that. Now there's another way to write that. If you keep in mind that correlation is computed as the standardized covariance, right? So the standardized covariance, so just, I'm writing all these, so R is covariance over, I'm going to make this bigger. So remember, R is the covariance of X and Y standardized, right? Everybody's okay with that? That's what it is. We standardize it and we reduce R to -1 to +1. Thanks for asking, Muscat. And so similarly, this is the correlation of I with the market returns. This is the covariance of the two, and this is the standard deviation. These are the standard deviation. So that's the standardized version. Okay, so that's correlation. Now if you take this formula and you put it into here, into here, you'll get this other version of the formula. Can you verify that? I'll give you a minute and then I'll show you how to do it. Okay, I ignored my phone. If you guys phone me or text me, I'm sorry. I'm trying to set things up. Okay, do you get the hang of this, or what I'm asking? So what you're going to do is substitute into here this would be so the notation is covariance, and it's the standardized covariance, I said, so each one of them separately. And then this and this. You see how that works? And now what happens? This cancels, and this cancels, and then there's two of these. So what does this mean? So that's the formula that I have right here. Okay, so what is it doing? It's scaling the covariation between the two by the variance. So it's like, it's the covariance per every unit, or I'm spreading out the covariation by the variation of just the market. And it's giving me a measure of sensitivity of the asset returns relative to the market. Okay, so these two formula, when would I use either one? Depends what you've been given. It's sometimes I'll give you data that'll be easier to manipulate and calculate the covariance, or maybe I'll give you the covariance and you just get the variance and it's easy. Or sometimes I'll actually give you the correlation. If you have the correlation, it's easy enough to get these. You can calculate this. Depends, right? Because if you have the correlation, then presumably you could get these other components from it. So these are all variables, they're all interrelated. You got to practice with these variables, and you have that opportunity in the other handouts I've given you, all right? So the test on Saturday will involve those kinds of questions. You need to practice them. You'll see what I mean when you start doing them, and hopefully we'll have some chance to look at some of those questions together. All right, so actually maybe we should do a couple of questions so you get an idea of beta. Oh, sorry, Carl, I didn't see that. Yeah, P for portfolio. Or you're talking about this P? This is correlation. This is correlation. So remember, from stats, I think I talked about it, the Greek letters, right? So beta is the Greek letter for B. Sigma is the Greek letter for S, for standard deviation. And correlation is an R, but in Greek it's a rho. It's like a rounded P. But it's not a P. It's an R actually in Greek. Okay, so let's see, maybe I can save this. Let's see if we can do something, look at some of those exercises. I gave you all the solution too. Let's see this one. 512. I did my update. It still asked me to do the update. So you see, you get to calculate. I'm just going to go through this. I'm not going to do exercises. Let's just look at what you got here. Okay, so these are similar questions. Some of them are similar to what to the other review, the first few. Now here I asked you for the beta. So here, some information, equally likely information. So when market returns are negative 10%, stock returns are negative 5%, market returns are 15%, stock returns are 25%. So here's my question. Is the beta positive or negative? Right. So when the market returns are negative, remember this is always on my X and this is always on the Y. When market returns are negative, stock returns are negative, but it's not perfect, right? It's a little less. When market returns are 15, stock returns are, this is more, and that's more. So this is higher. It's positive. When one is positive, the other one is positive. When one goes up, so if you go from negative 10 to 15%, stock returns for Y go from negative 5 to 25%. So when this one goes up, the other one goes up as well. So there you go. That's how you would look at something like that. It's going to be a positive. Maybe just looking at the negative, that's positive because that's less, that's less negative. So that's positive, and that's positive. So from here, I want you to calculate the beta and the correlation coefficient. Again, there's just two observations, so you can just do the regular slope, change in Y over change in X calculation. You don't have to do the, you don't have to do the fancy statistics one. You just can do it like that. And then I ask you for the correlation coefficient. You can put them in your calculator like I taught you, right? There's only two, and you can get the R from the calculator. You see how I'm going to make it easier for you? If I tell you to give me the formula, you're going to have to write it up with the formula, but then you can just use your calculator to get your answer. So here I give you information on beta, and you need to interpret it. So you get the expected returns, standard deviation of beta. Like these are the statistics, you see? Alright, so I'm just looking through this. Okay, again, I just asked you for beta. So there's a lot of questions with beta starting on the second review. So let's go back to the notes so you know how to do those before the end of the class. If ever in doubt, just plot a few of the values and you can see the trend. Just plot them in a scatter plot. All right. Now what? Okay, what we have to do is like kind of a tangent here because I need to tell you something about portfolios. So we saw that combining stock into portfolios can reduce the standard deviation. It's the covariance that creates the correlation that makes that possible. The standard deviation of portfolio P, so this is a different P than the row for the correlation. This is P for portfolio, with some percentage, we'll call it XA, that's invested in A, and 1 minus that percentage invested in B, that's XB. These are the formulas that I introduced you to last time. This is the standard deviation of the portfolio. This would be the correlation, which you could write this way or this way, right? From there, I can also have a second formula that might be handy, where I plug that in, or no, let me say I plug this in there, and I get this version of the formula. Again, why would you do that? Well, software, not just software pushes out a correlation, but also it's more intuitive to have the correlation versus the covariance. Okay, but they are related by this formula. And what's this formula again? Again, this is the formula. This is the standardized covariance. We're standardizing the covariance, reducing correlation to an index. So in this case, I have A and B. So don't get intimidated. I'm just talking about A and B rather than I and M right now. I'm talking about a portfolio now of combining assets. That's here. It's not like, this is the same correlation, but it's between here, it's between assets and the market portfolio. Okay, so this is already a portfolio, and I'm considering another separate asset and its relationship between the market returns, so the returns on that portfolio. Okay, so how am I gonna? Okay, so there's a portfolio that you create with 2 or more assets, and when those assets represent stock that are risky securities, common stock, and the stock market, and they're all combined in relative proportion to their value outstanding, you put those together in an index, and that creates a market portfolio. Okay, so just to distinguish between this kind of portfolio where you're creating one and the market portfolio that represents the economic performance. Okay, because it's like I have all the same symbols but with different subscripts. Keep it straight in your head. Alright, so here are combining just 2, right? This is the formula for 2. Looks like I focus on just 2 most of the time, but you could do this for more than 2. And what we're going to do, I'm introducing you to Markowitz portfolio theory. Consider 2 assets, asset Y and asset Z. Here's the information on the assets, the returns, standard deviation. Now combine them in a portfolio P. So the expected return would be this, and you should be comfortable seeing that here. Now I'm not saying what the weights are. Okay, this is what they would be. This would be a formula to calculate the expected return. Okay, so remember, okay, let me go back. So I'm going to put at Y and X into a portfolio, and I'm going to do it, so I'm going to spend, some money. So example, $1,000, and I'm going to put $600 worth of Y, and then $400 worth of X, not X, Z. Just with me so far? So what proportion, so what would be Y, sorry, X is reserved for the weight. So X, Y, what would X, Y be for that example? And what would X, Z be for that example? Tell me. This is just an example so you guys are not lost. So those are the weights. So 600 divided by 1,000 is 0.6. And 400 divided by 1,000 is 0.4. And when you add them together, they total 1. Those are the weights, x, y, x, z, or z. Good. All right, so I made this expression here because I want to answer the question, what is the correct weight for each asset? Like, what, $600 of Y and $400 of Z the right thing? I don't know. I'm not sure. What about, how can I compare it to other things? So this is what Markowitz portfolio theory is going to introduce us to, finding the optimal weights. So here I have the expected return, and the standard deviation is this calculation here. And you see what I've done? I keep my symbols, right? So those represents the weights, but I'm not going to put it in. Looks like I got an error. Okay, it's been an hour, and this is my getting a message about buffering. Sorry. Let's take a minute, just a couple minutes. I'm going to see if I can set up the Ethernet here where I am. I had to move into a different area. Okay, I'll be right back. Okay, I'm back. I just set up the Ethernet as opposed to the Wi-Fi. I usually have them both on, but it wasn't working. And if any of you are worried that you're going to lose contact with me because I'm going to Puerto Rico, don't worry. My internet is good over there. And just because I don't, I'm actually broadcasting from my sister's place because I usually stay with my family when I'm in town. All right. All right, what was I saying? So we're setting up a formula for the expected returns Oh my goodness, sorry again, interruptions. So what we're going to do is create a formula for the expected return considering different combinations of weights. And we have the standard deviation with those different combinations of weights. So here's a formula for this specific example, right? And this is a measure of return, and this is a measure of risk. And what we're going to do is create an illustration of all the possible combinations of the two assets in a portfolio and the resulting risk and return that you get. So I've just presented 3 possibilities here. Alright, so what you have here is, well, there's 3 things to tell you. One is I give you the combination of weights. So what if you put half and half of each? What do you get? So you should get the feeling that, I'm just picking these out to show you 3 different possible combinations of the two assets in a portfolio, but you could generate this for all possible combinations with a computer program, or with the computer you could do this. So let's see. So I've shown you here the different possible combinations, half of each. Here you have more of Y, and in this one, number 3, you have more of Z. Now, what I've also left out is, because I want to show you the strength of this theory, I've also left out as a variable. So the variable is your choice variable. You get to choose as an investor or as a fund manager. You're going to choose how much of each to put together. And we're going to do it in different states of the world. So notice I allow the correlation to vary. Okay, so what I'm saying is, what would this look like for different types of relationships? And this is going to map out all the possible combinations and all the possible relationships. Okay, it's quite powerful. But I've done it with some numbers. I've included the numbers for these two securities, the statistics we have on them, their own expected return and their own standard deviations. Okay, so what you see is I could actually plot these, and you should be able to do it sitting with your notes. Plot this out, because you're going to have to do it when you review the exercises. What if these securities are perfectly positively correlated, uncorrelated, or negatively correlated? What do we see? Where correlation, remember this is the R, right? Correlation is between -1 and +1. So I've picked the extremes. No correlation, perfect positive and perfect negative. If we just go back a moment and look at the relationship, I don't have anything information on the relationship, I just have information on the two securities. So which one is more risky? And which one has a higher return? The more risky one is Y, so keep that in your mind. And Z is not, right? So along with the higher risk as anticipated, we also get the higher return. Okay, so so Y is the higher risk, higher return portfolio, asset, and Z is not. It's the lower risk, lower return one, relatively speaking. So now we're going to get into this. So let's see the plot. What I've done here, I saw in the class list, many of you are engineers, so you should feel comfortable with this. You're engineering students, I should specify, that's true, but engineering, you should be able to follow this discussion. And the rest of you, let me know if you're not getting what I'm doing here. So what you have here is the 3 different scenarios for all the possible combinations. So let's see. What is this scenario? What's happening in this one? And what is this one? And what is the one in between? Scenarios like, oh, well, it's below. So you could plot to prove these. You could see those values in the table, the previous table, are plotted on this chart. But I wanted to show you the extremes first. So the extreme scenarios are where they're perfectly positively correlated, where they're perfectly negatively correlated, and when they're somewhere in between would be here. The one I gave you was 0, so I wrote it like, sorry, it was like so this one is the one. Jeez. That was for correlation of 0 particularly. That's the one that you have. Okay? But anywhere in between those two of positive and negative correlation, makes this sort of a shape. At 0, it goes straight up. It's not a coincidence. What is this doing, this back bending? What is this accomplishing? What you have on this axis is return. This is a way to see the risk-return trade-off. And on this axis you have the risk. So what is this back bending giving you? Anybody? What is this back? What is this accomplishing? This. So what do we have here? Okay, look. So let's talk about this. So what we have here is what? Let's go back to the chart above. So I'll come back to this in a second because that's kind of a more general statement. These are the numbers. These are with the numbers I gave you. So this is Z. In America, it's Z. In Canada, it's Z. So this is Z, where you invest completely in Z. You have the expected return and standard deviation of Z. Right? Let's go back and see Z. Remember? Z was 1.2 and 14.4. And the other one was 10 and 20. So let's see. See, 1.2, 14.4 is Z, and up here is the 10.2 and 20. You get it? So that's Z, and that's Y. This is low risk, low return, high risk, high return. And now between them, if we combine them in a portfolio, more of Z or Z will put us closer here, more of Y will put us up here. So let's take the first scenario. Well, the first one is where correlation is -1. So where it's -1, that's perfect negative correlation. The perfect negative correlation, like in the more general plot below it that we just discussed, it goes all the way back. So these are different combinations. So which one should we pick? If you're in this situation, correlation equals -1. In that scenario, which combination of all these possibilities should we pick? Which one do you pick? You can tell me, let's see, and give you some options. I don't know, just see if you can tell me which one is the best here. Is there a best? So you can tell me by the, well, I don't want to give, if I tell you how to tell me, then I'll give it away. So which one of these is the best if correlation is -1? What are we looking for? Okay, so let me ask it a different way. Which combination would no rational investor invest in? Nobody knows, hey? So notice something's going on here. So how are you going to look at this? We like returns, we don't like risk. So we want to be Okay, Alan. So yes, you're torn, right, Alan, between 0 risk and 100% Y. No, it's good. That's exactly how you're supposed to be thinking. Something's going on here. This is the easiest case to start on because it's profound that you will get 15.8% return. I think I marked it here with 0 risk. Because that exists in all the possible combinations, like let's say you can combine them. Any of these possibilities is let's say has no additional cost. Okay, so let's say there's no additional cost of any of these. This one would have the lowest risk, so this would be a starting point. All of these below it are not rational, because for a greater measure of risk, you get a lower return. So nobody's going to go for this. They're going to start here and consider these possibilities. Okay, so these are known as the efficient combinations, efficient portfolios here. Got it? So some people would say, oh, I'll go for Y, and some people might say, well, I'll stay 0 risk and stay at 15.8. They would all be rational people. It's a matter of how much risk you're willing to take on. Okay? There's a trade-off. The trade-off starts here, though. Here it's clearly indicated no one rational would pick any of these combinations. Oh, okay, Alan, you're looking at the whole thing now. Okay, no, all right, so let's see. Let's go back. So in that table, all that's happened in that table there is I gave 3 possibilities. In the table here, I showed you just 3 possibilities, but there's really infinitely many possibilities. Portfolio 1 is 75% in Y, so more of the risky one, and 25% of the risk, like the lower risk one. And if you are with portfolio Y, if you calculated that, your expected return is 18.6%. Whereas the standard deviation of the portfolio depends on the correlation. Okay, but that's not what I wanted to talk about. I want to talk about what I'm talking about here is just the general case, because that's actually, you could show using those calculations, identify them here, those 3 options. So this one here would be 100% Z and 0% Y for your weights. And then as you move over, you're putting less Z and more of Y in. So the question, the really important thing, never mind the table that I gave you, the real important thing is I want to know what this one is. This would be called the minimum variance. I got to write it better. The minimum variance portfolio. And from the minimum variance portfolio, I need to find out what weights would give me that one. And then, so that's going to be some, some of Y, but more of Z in it. But to find out exactly what it is, there's some way, I have to find a way to relate it to the 0 standard deviation, and that's what I'll show you. So from the efficient portfolios, it depends on the investor's preference for risk. Okay, so it's relative. It depends on the investor's risk preference on which one they're going to pick. But the point was, no one's going to pick those. What if the correlation is positive 1? Positive 1 would be the one below. So they're perfectly positive. So there is no, so what's the difference between this one and this one? This one and this one. A very clear distinction is there's no backward bending of this one. In other words, there's no diversification possible. So this is diversification effect. That's what you're seeing here, that this bends back. All right, so that's diversification effect right there. Even here, well, here you don't have it because it's zero correlation, so there's no diversification. It goes straight up. And here there's no diversification because there's no negative correlation. They're positively correlated, okay? So that is what's going on there. It's all about correlation, the dependency on of correlation that determines the shape of the combination. So these are the combinations, and the table is just if you wanted to pick the two weights for options 1, 2, and 3. You can see where they plot on here. I've marked some of them, so you guys can look at that. So you see, for perfectly negatively, you have that extreme. For perfectly positive, there is no diversification, so they're all efficient. And then for 0, this one was 0. There's no diversification, but these are the combinations. Right, so the question is, Kyla's asking, is it in general? Then this is the one I showed. This is general. So in general, as long as the correlation is between -1 and +1, the backward bending will happen. Well, it'll bend back. It'll bend back until p equals 0. Really, at p equals 0, it won't bend anymore. It'll just do this. It'll go up and over, and then become more. It won't bend back after rho equals 0. Okay. So what I'm showing you is in here, in this whole shaded. I'm going to shade this area. Are all the possible combinations with the correlation between -1 and +1. So you're thinking about different things. You think on the one hand, what's the best combination of two assets in a portfolio? And the second thing is, what's the best combination given the correlation? The correlation you can't choose, right? That's just given. That's just the relationship between two securities. What you can determine, what you can choose, is which combination. No, Kyla, you can combine them. No. You can combine them. Look, again, notice, let's go back here. The point about diversification is that, so you can combine securities to make a portfolio in all cases. Negative correlation, positive correlation, zero correlation, or anything in between, a negative and a positive. The issue is that if there's diversification, several combinations will not be efficient. Those won't exist. People won't choose those. Rational investors won't choose those. They'll only choose the ones where it's going monotonous, upward. Okay? Again, these are not chosen because this is lower standard deviation, right? For lower standard deviation, you get a higher return each time. So you won't pick this one. What about a little bit of Y? A little bit of Y, well, of course, somebody would pick that one because that'll give me lower risk but higher return. A little bit more of Y than that, all the way to here, will give me this one with zero risk and a better return than all those below. Right, so these ones here, it wouldn't make sense to do it. So when the correlation is between 0 and -1, there are some inefficient portfolios that won't exist. Okay, so you could do better by diversifying is the point. But when they're positively correlated, there is no diversification effect. You just have to choose, given risk preference, which one you'd like. Right. Yeah. The point is that these wouldn't be considered efficient. Where's the point when Y is 100% and Z is 0%? Right here. That's Y. Good, you guys are getting a hang of this, looking at this, because it's really intimidating until you just break it down. So this is 100% Y and 0% Z. Or Z. Stuck on saying Z. Alright, so that's why we have between Z and Y, or Z and Y, and then these three different alternatives. Really, they're scenarios, I'd say, because they're just the state of the world where the correlation is negative, the correlation is positive. And I gave you some numbers just so that it's not so abstract. And just here, you can go through and identify, let's see, what did I plot here? So 15.8, is that there? No. Okay, so portfolio 3 here, you see this one? This is, portfolio 3 is this one. So this was like what I said, mostly Z in it, or Z, and 25% Y. So just a little bit of Y. And that will put us here. And with that combination, if you put it in the formula of the standard deviation will be 0. So you could make an Excel spreadsheet with a graph that connects. You could calculate, you can make a column with the weights, different combinations of weights, and then you could plot the return. And you could calculate the return, you could calculate the risk in the next column, which would be the standard deviation, and then you can make a graph of the two for 3 different scenarios. Correlation -1. I don't expect you to do this, but this is how this was done. Correlation is 0 and correlation is +1. Exactly, Kyle. It's 3 graphs in one, exactly, to show you the theory down here. Okay. So remember that you have, most of the time you're going to be in here. If your correlation is negative, it's going to back bend. If it's positive, it's not. It's going to go at 0, it's going to just go straight up. No added risk, but higher return. For more, combining more of this risky one. And then all positive. So these end up being efficient because nobody would pick, if you compare this, let me make this bigger. So here's another thing that you would compare, like this is supposed to be straight up and down. So these wouldn't be efficient, right? Because a little bit more of, let's say, y was up there, so a little bit more of y all the way up to here, you haven't affected, this should be a straight line, you haven't affected your, risk, you haven't added risk, you're only getting higher return. So the best return is this one, and then after that, you're adding risk, so it's a trade-off. So it's demonstrating the combinations and up to where you have the trade-off. Trade-off begins here, and that's where investors, depending on their risk preference, prefer different combinations. All right. Okay, you're better with this? It's not so bad? Let me know. It's a little bit better. What's going on here? So there's infinitely many combinations. I just showed you 3. Okay. And you could try and plot them on here for yourself to prove to yourself that the numbers match up. So it's 3 different combinations in 3 different scenarios. Okay, I'm proud of you guys, of course. Okay, so now what? So, theory now. Let's get to the theory. So this is kind of wrapping it up and going forward. So expected returns and standard deviations vary for portfolios with 2 assets, depending on the different weight combinations of the 2 stocks. The feasible set in general would be all of these different combinations here. So you could actually calculate weights that would get you those. However, the efficient ones, the ones that would exist, would only be from the minimum variance portfolio up to the more risky one. Okay? So what did I write here? 75% in C and 25% in Y would be like, yeah, I'm just trying to show you this is some combination of the 2. All right, so that's just 2 assets at a time. But really, portfolios include several assets, more than 2 assets at a time. And remembering from our formula of variation or variance, we take 2 at a time, right? We take 2 at a time, and it contributes to the risk measure, right? From the matrix, how we did the matrix last class, we take 2 at a time. So in considering several assets or multi-asset case, each eggshell represents the possible weighted combination for 2 assets at a time. So let's say you have, we just have like asset A and asset B, and asset C and asset K. So 2 at a time, asset J and asset L, right? And they, at 2 at a time, you get, these eggshells. Now, if you start combining more than 2 at a time, you're going to, like, which ones should you pick? Which combination should you pick of assets? Now, these two, notice, they have A and B here, right? Well, A and B, let's look at A and B. Let's see. Just making names. So you have P and F. Notice A and B, this combination, these combinations here are not as good as the combinations like over here, right? The P and F. Because there's less risk in some of these combinations without compromising return or even higher return. So what is this doing? So we're thinking of 2 at a time, but in fact, if we have this, we create like a multi-dimensional consideration of an asset, like a multi-asset case. We are interested in still the same concept that we want low risk first of all, the lowest risk that we can get without affecting the return, and that would create this smoothed out envelope of all these assets 2 at a time and beyond combinations. I haven't done the multi-dimensions here because I can't draw multi-dimensions, right? I can just draw 2, and then I could draw 3, but I'm not going to put it here. But in the multi-dimensional case, we're imagining that this is going to touch several assets at the same time for the best combination given people's preference for risk. But none of these combinations down here will be selected for the same rationale that investors can do better reducing risk and improving return all the way up till here. Then from here, all the combinations on this envelope have higher risk and higher return. They exhibit the trade-off that we talked about. So we say the feasible set is on the inside of this envelope. The composite of all asset sets are on the envelope, and the efficient frontier is just that which starts here. Okay? So we consider all possible assets. Theoretically, you can also do this, like you can do this mathematically, but if you list all the information on assets, your goal is always to move left and up. Because why? Because you're always reducing risk without compromising the return. So securities that are higher risk with low return will be dominated by securities with lower risk and higher return. So this is up and to the left. So we always want to be here. All right. What do I want to tell you about? Okay, so up and to the left. So now I'm going to introduce the concept of short selling to you. Does anybody know what short selling is? I mentioned watching the movie The Big Short. What's short selling? Well, it's good to know when short selling happens. Yes, all this is on the test on Saturday. Short selling is the sale of a security that an investor does not own. So when would this take place? Let's first talk about right. So short selling, I'm just saying Tanner, yes. So what's happening, I mean in that film that's what they were doing, but in terms of, let's just deal with it in this context and then I'll be more general when we talk about options next week. In short selling, an investor would make an arrangement with his broker to borrow the security and then return it at a later date. So why would they do this? The idea would be that they believe that they can do something with the proceeds from selling that security that would benefit them, would profit them, and then later they'll return the security. Now, it could profit them two ways. If they have an idea of what they can do with this money, that will do better than just purchasing the security. That could happen if the security's price actually fell over time. So shorting or short selling happens when an investor or a speculator, someone considers or has information possibly, or he used the information in a way to determine that an asset is going to perform poorly in the future. So they have some sort of notion that a firm is going to do poorly. So they'll borrow the security up front, make a commitment to return the security in 3 months' time or some remote time. And so they then take the security, sell it, use the money for whatever they intend to do with it, other investments. And this is how we're going to use it in this example, you'll see. And then later, when they have to buy it to return it to the broker, it would be a bonus if the price actually dropped, right? Or at least dropped to a rate lower than any kind of profits they earned over the interim. So in this case, I'm going to introduce a notion of riskless borrowing and lending. Okay, but I first introduced short selling, and we're going to talk about it when we talk about options next week. So you're going to borrow the security from the broker and sell it in the open market to get the proceeds. At the initiation of the short sell, your only cash flow is the proceeds from selling the security. Then you have to close the short. To do that, you actually have to purchase the security buy it on the market and return it to the broker. At the elimination of the short sell, your only cash flow is the price you have to pay for the security in the open market. Okay, so you've borrowed it. In reality, there'll be transaction costs for doing that, but we're going to ignore that for the theory that I'm going to present to you. Well, there are people, so on each trade, there are two sides to the trade. So somebody on the other side of a short sell has a different notion of what's going to happen. Okay? So they're willing to sell it or loan it to the broker so that the broker can give it, and then with a commitment to give it back later. So they have the opposite notion of what's going to happen with the security, and they believe they're going to get a higher valued security back later. I mean, there's two sides to every trade, okay? And there's two perspectives and beliefs about what's going to happen. All right, so let's use this example. Well, the one we're going to focus on for the remainder of this class is the short sell of a treasury bill. Remember, a T-bill is a zero coupon bond issued by the government with a face value of $100. And with a maturity no longer than 1 year. So often you talk about the 3-month, 90-day T-bill. If the yield on a 1-year T-bill is 5%, then its current price can be calculated just as a discount, just a time value of money, right? $100 discounted, that's $95.24. So this would be the current price. So what's going to happen, you make the arrangement as an arrangement to borrow the security, the short sell, borrow it for a year from your broker, and sell it on the open market immediately for $95.24. So this is the cash flow from the sale of the T-bill. A year later, the investor has to buy it back the instant before it matures in order to return it to the broker. The price you have to pay for the T-bill is in the open market an instant before maturity in 1 year is $100. This is risk-free borrowing. So this is not exactly what this is not the case of the short sell that I was mentioning and why people would short sell stock, but this is actually risk-free borrowing, where you're borrowing this money. Transaction is equivalent to borrowing this money for 1 year and then paying it back for 100. And in the meantime, the belief is that you're going to make some money, enough money to investing that $95.24 to buy back the T-bill and maybe have some sort of extra for yourself. The interest rate, if you work it out, is the return over the price gives you a 5% yield. Okay, so the face value over the price gives you the 5% yield to maturity. All right, so we have all these pieces. Now I'm going to put it together. Here are the pieces. On a axis where I have risk and return, this is risk. I keep on reminding you because I want you to be aware of the different axes you're dealing with, and return on this axis. remember this eggshell, right? So in here, all the possible assets, and then along this line are the efficient portfolio combining more than two. I was showing you two at a time, but in essence, you can have, this will touch on several at the same, well, right here, it could touch on several at the same time, okay? So they're all combined and interacting within the eggshell shape. And so which one do we pick? So this is the initial question. Which one should we pick? And I mentioned to you that it depends. Okay, Ben is just asking me if the person lost money. No, because I haven't included here what he did in the meantime. And that's what I'm going to show you now, Ben. Okay? It depends what he does with that money in between. So if he made more than $100, because he took 95.24 for each T-bill, and he did something with that money. He paid back the bond later, the T-bill later, but in the interim, maybe he made something. And so I'm going to show you what he could do with that, okay? So which one does he pick? Okay, so now we have here, I'm going to introduce to the risky assets, I'm going to introduce the risk-free asset. And here it is, right here. No problem, Ben. So I'm gonna plot it here. It goes here. Remember the risk-free asset, and we'll use the T-bill as the risk-free. Remember what I told you about the risk-free asset. The standard deviation is 0. It's risk-free, right? And its return is here. So what I'm going to do is create a line. In creating this line, I'm going to lay it tangential to the efficient frontier. And it's going to touch right here. What this point is marking the correct combination of risky assets in the market portfolio. So the big M represents the market portfolio. Many assets are in there. Actually, all assets are in the market portfolio. All risky assets are in the market portfolio. And they're in there in proportion to how much stock is outstanding. So, and they're in relative proportion to stock outstanding. So if a company has, I don't want to do all these numbers, but basically if a company has more stock outstanding or higher market cap, so more value of stock outstanding, they'll have more representation in the market portfolio, okay? Greater representation of the total. Okay, so I create this line. This line represents a linear combination between the market portfolio, so risky assets, and the risk-free one. So if you're here, all you have is the market portfolio. So you're invested in like an S&P TSX index, and you're just earning the return, like we said, over time in the United States, it was 11% over time on average. But you would get that if you just invested and left your money there to just follow and track that index. And over time, you'd realize that return. So that would be that. But combining it with risk-free borrowing, you can expand your possibilities beyond the eggshell. Higher return, but yes, higher risk. There is a trade-off, but you're expanding beyond. How are you doing that? How are you accomplishing that? Because you're taking the proceeds from the risk-free borrowing it and investing it into the market portfolio. So you're investing yourself, you're over-investing in the market portfolio. That gives you a chance at higher returns, but it does increase your risk. Okay? So, this is... so I've showed you what M is. I've showed you what this is. This is where the risk-free rate is. So if you just invest in the risk-free rate, you're just here. Someone who just invests in T-bills would be here. Okay? Someone who invests part in T-bills and part in the market portfolio, so like 50-50, so they make a portfolio for themselves of risk-free and risky assets. So risk-free T-bills and risky assets. They'd end up somewhere like A. So what does it mean to purchase a risk-free asset? It means you're buying T-bills. When you buy T-bills, you're actually lending. Okay, you're lending your money away and then you're getting a return. So this is more safe. It's lower risk, but low return. So let's say you want to go beyond that. You go for A little bit of risky, the risky assets. Well, not, it's like your portfolio will be made up of risky assets, but not entirely. It's going to have half and half, risky and risk-free. Then you have here the pure market portfolio. Beyond that, this is short selling. Here you have the market portfolio and short selling to invest in the market portfolio. And you can end up somewhere like B. And I'll show you an exercise where I actually carry out these calculations in a minute. So what do we have here? This is borrowing on this side. You're borrowing to invest in the market portfolio. You're borrowing to invest in the market portfolio, or short selling. And here you're lending, okay? And here you are invested solely in the market portfolio, so all risky assets. So lending or borrowing at the risk-free rate allows us to exist outside the Markowitz frontier. So this was the Markowitz frontier, the efficient frontier. And like I said, in portfolio A is investing both the market portfolio and risk-free assets, and B is by short selling the risk-free asset and holding the market portfolio and investing that borrowed money in the market portfolio. Okay, let me show you. Okay, so Kyla asked me, are there other ways to, not in this world, Kyla, in this abstraction, so each of these scenarios are abstractions from, like I made a number of assumptions here to do this, and like I said, there's no transactions cost to picking several of the combinations, and I said all the risky assets exist in this market portfolio, and then, but in this world, the way I've set things up with only one T-bill, one risk-free rate with zero standard deviation, to get B, you've got to be over-invested, borrowing at the risk-free rate and investing in the market portfolio. Right. M is just the market portfolio. It's just risky assets. By placing the line tangent, it helps me pick it, however. Okay? By laying the line tangent, expanding beyond the Markowitz frontier, I pick one combination of all of them. So that helps me pick the right combination of the assets. So you have to remember, all the assets are in M. All risky assets are in M. All investors All rational investors have M in their portfolios because they have to be on the efficient frontier. This is known as the capital market line, okay, CML. So this is CML is the new efficient frontier. So we went from the Markowitz frontier to the new efficient frontier. All right, let me pull up the exercises again, and I'll show you where you get to practice that. And I give you all the answers, and what you can do is, let's see, today's Thursday, Friday, and the test on Saturday. Oh, this is what when I was thinking about the schedule, I mentioned that the exam is going to be given to you at 4 a.m. because my flight leaves at 6. I'm leaving, well, 6:30. So I'm leaving at 4 from my home here in Winnipeg. So I have to give you the exam at 4. So if any of you want to wake up early to do it, go ahead. But I need to send it earlier. I can't guarantee where I'll be at 9 o'clock because flights change a lot these days. I'll be unable to reach you to send the exam. Okay? So you got more time for this one. So I'm trying to think if I have time that I can answer questions. Well, I guess I'll just take questions, email me questions. I don't know what to say. It's really tight tomorrow. I have to sleep early. So, well, do your best on the test. You have all these materials. I'll just show you most of the answers you have. I'm going to change some of the numbers, obviously. So let's see. I want to show you this one, number 2 again. No, I don't think this is it. Yes, Andre, I said at the beginning that on the exam, I'm going to put 30 to 35 questions. Oh, you're talking about test 2? Sorry, test 3. I don't know how many questions are on test 3. I have to look. I made this a while ago. I'm trying to remember what I did. You know what? Because I have to add some questions to the test that I gave before. So I'm going to have to do that too. So I don't know how many questions, Andre, but you should be able to finish it in like 11 hours. It's more like an assignment, and I do encourage you to do it on your own. I want you to do it on your own. You're not supposed to get help on these. Okay, no, it's not on this one. Okay, so this one is just more of the same, statistics and things. Okay, so that's a good exercise. You should be able to do that one. This is a very good exercise. Sorry, I had an interruption. Okay, so let's see. Okay, portfolio. So 514. So I said I was going to turn this off, right? And start another stream. I don't feel like doing it. I don't feel like doing it now. I'm gonna just keep going. I'll find the stream like I just did last time. I'll locate it, the 4 hours. I don't know what's happening with YouTube. It kind of changed its setup. All right, so let's see. No, this is not the one. Oh, this is it. So this one is good. So this is an example of Markowitz portfolio theory where we should just do this. Let's do this together. So I'm going to show you how you find combinations. So here we go. T-bills, this is the risk-free T-bill. 4% is the expected return. The market portfolio is 12%. And we're trying to find out the portfolio combining risk-free and risky. Oh, sorry, what is it? One sec. $5.15. Portfolio theory, $5.14. Okay, so 514. All right, you with me? So now we're going to figure out, we're going to find that portfolio Y on that CML? Yeah, CML, capital market line. And I give you information for that. So $400 of Y is invested in the market portfolio. So what do you know? If $400 is in the market portfolio and it's $1,600 invested in total, what is the investment in the market portfolio? What is the weight? Anybody? You have the solutions there, but don't look, please, unless you. I mean, you'll have time to look at that later. $400 of the investment is in the market portfolio out of 1,600. Right, so it's 4 out of 16, right? Which is a quarter. That makes sense. Okay, that's 0.25. All right. And then what about the other weight? So if the market portfolio is 25%, how much in the risk-free T-bill? Well, they have to add to 1, so this has to be now, what is the expected return for that new portfolio? 25% in M and 75% in T-bills. How do you figure that out? So what I'm doing is I'm using the portfolio theory of the statistics that we talked about last class, and I'm using it to combine risky and risk-free assets. So this would be, the expected return will be the proportion that you put in the market portfolio times the expected return on the market portfolio. What's the expected return on the market portfolio? What does it say up here? So you're doing a weighted average of the two. It's 12%. Weighted average. So because we do weighted average, we get these lines because we're doing linear combinations. That's what we're accomplishing here. That's why they say algebra is really important for this class, because linear algebra, linear combinations, that's what we're working with. So when you put this together, what is the expected return? We'll just put there what XM and XF are. So it's a linear combination. It should be evenly between, not evenly, but it should be between 12 and 4%. And you get, you say 6%? Good. So this works out to be, when you make the calculation, 6%. Okay, good. All right, so you guys got that. So let's get rid of those weights. So this is 6%. Now, what would be the beta of y? Okay, so now I have to teach you about beta. We're going to go back to the betas, which we're going to do next. But you get the idea of this handout, right? So I'm combining. So you guys can, you have the answers. I'll work through this. I'm going to talk about beta now. Let's go back. Oh, that's not what I want. I want notes. All right. Okay, so we have risk here and return here. So this shows the risk-return trade-off. We've identified the efficient portfolios. Talking about risk-free, talking about risky assets, and a combination, and the preferred one of all these efficient ones is combining with the risk-free because it expands beyond the eggshell possibilities. Right. So now, all securities are in M. All investors have M in their portfolio since they are all on the new efficient frontier, the CML. Investing in both the risk-free and the risky assets. So this shows you investors are only concerned with the expected return on the market portfolio and the standard deviation of the market portfolio, and with the contribution of each security I to M. I'm just reading the next slide. In terms of the contribution of systematic risk measured by beta. So the contribution of systematic risk measured by beta and the contribution of the expected return. All of this brings us to the capital asset pricing model, okay? A capital asset pricing model demonstrates a way of using the beta, this thing, you're going to tell me what that is, and the risk-free to determine the expected rate of return for an asset. So this is taking into consideration the sensitivity of any asset to market forces, we are going to adjust the risk-free return. So this is the idea. We want to figure out what should be the expected return for a security. And remember, I promised you until some point I was going to give you the required rate of return, or the hurdle rate, or the I that you're supposed to use, a firm is supposed to use when valuing projects, and investors are supposed to use when valuing stock. I was going to give you, I always gave it to you, but now we're actually going to determine what is the required rate of return. The way we're going to do that is now using the capital asset pricing model. We're going to spend a little time on this. The capital asset pricing model adjusts the risk-free return. Why? Because all rational investors hold T-bills, right? Because they want to offset. We talked about offsetting or hedging against inflation, right? So investors will hold risk-free assets. To be incentivized to hold risky assets, they must be compensated. Now, what does that sound like? What is this? What do we call this? Come on, somebody. Right. And in particular, Kyla, it's the risk premium, but which one? Yeah, which risk premium? Because you calculated risk premium for different asset classes. Which one is this? Market. Very good. So this is the market. This is the market risk premium. You guys see that? Okay, so that's the market risk premium. So what we're going to do is put this all together and say, and with risk-free borrowing and lending, all rational investors will hold, they'll possess risk-free T-bills. To be compensated to hold more, risky asset, they must, sorry, to be incentivized to hold a more risky asset, they need to be compensated. For every unit of risk every unit of contribution to systematic risk, that's the beta, they will have to be compensated the market risk premium. Okay, so if this is 1, they get compensated by the market risk premium. If this is greater, they have to be compensated by whatever it is, 1.5 times the market risk premium. Got it? And that will give you the required rate of return for that asset. And then you can use that for valuation. Okay, so right. So what do we do here? So just remembering, what's the beta? The beta is that slope, the statistics slope I talked about. And things aren't necessarily on a line, but we can find the least squares prediction line. This is that slope, the least squares prediction line. You can also write it like this. As I explained, we spread out the covariance over every, per unit of the variance of the market. And keep in mind that the beta, the sensitivity of market returns to market returns, that's what this actually means, is going to be 1, right? It's 1 for 1. So that's a special case. For any asset, though, you would use this calculation, but if I ever write beta m, it's always 1. So what does that mean? Why do I say that? Because now what I'm going to do in terms of risk, I'm going to plot risk as the beta now, because all I really care about is the systematic risk. This is the beta. This is the return. And we have a new set of axes. It looks like the similar line that we have for the capital market line, but this is called the security market line. Okay, let's take 5 minutes. I have to do something, to look at something. Take a break, and we'll meet back here in 5 minutes, okay? I'm going to be on till 10:15, just to let you know. If you have to leave early, it's fine with me. Just check back with the video. Okay, had a good break. We're back. So let's look at this. This is the capital asset pricing model. The SML shows us all linear combinations possible between the market portfolio and the risk-free portfolio. And now I think Kyla mentioned, can you get them different ways? Okay, let's see what she was saying. It's Kyla who mentioned that. All right, this is what I think you were referring to. So here you have combinations, risk-free lending with the market portfolio creates all these combinations. Risk-free borrowing creates all these possible combinations for the market and the risk-free. On the exercise page I was showing you, actually let's just show you that. Yeah, okay, let's finish this and then we'll go to that. Okay, we'll go back to that exercise. So what you have here is the market portfolio has a beta of 1, always, and that's its expected return, ERM. The risk-free has now a beta of 0, right? It's right on here. Everybody okay with that? Remember, the standard deviation is 0, but also the beta is 0. We're going to take some time to compute betas in a bit. But everybody's okay with that? Remember, the beta is R times SY over SX, where Y was, right. Right. So for the risk-free, the standard deviation would be 0, so the beta ends up being 0. Everybody else okay with that? So I plotted here all possible combinations between the two by lending and holding the market portfolio, and then here by borrowing, risk-free borrowing in the market portfolio. Oh, there's so much to say here. So what we have here is, again, to be compensated to take on more risky asset than the risk-free T-bill, investors have to be compensated for every additional unit systematic risk contributed to the market portfolio by holding an additional asset I. They need to be compensated the market portfolio. Okay? It sounds like it's circular discussion, but if you practice, you'll get the hang of this. All right, so then I just want to ask you a question. What's the slope of that line? What's the slope of the SML? Anybody? Trick question, right? It's not beta, because beta, look, is here. So beta can't be the slope. Beta is the axis. the slope is actually here. The market risk premium is the slope. No, the market risk premium is the slope. So for every additional unit of risk, to get back on the line, you have to adjust with the market risk premium. Okay? That's the slope. I mean, if I put the beta here, it would have been easily an easy answer, because the beta is like the x. So just to remind people, so like y equals a plus bx. That's why you thought it was beta was the b, but no. This is the slope measure of a different axis, okay? In fact, the calculation of the beta is plotted here. Okay, you guys getting something here? I hope it's not confusing. So the slope is actually this, the market risk premium. Okay, so what's the difference between CML and the SML? On the SML, I'm using the standard deviation, right? The standard deviation of the risk of the portfolio. On the CML, I'm using the standard deviation of the portfolio. On the SML, I'm using beta as a measure of risk. And with beta, now I'm going to be able to price, or identify the required rate of return for securities using this calculation. And what it means, what it tells us, well, what in fact is the case is all securities are on this line. All securities are on this line. They can be recreated. I mean, returns, all investments, all projects that exist in efficient market are on this line, okay? So, nothing in a market clearing setting exists off the line. So I'm going to teach you how to deal with cases that are offline and to return them to the SML. So what it means, and what Kyla was getting at, I think, with the SML is you can create combinations of riskless and risky assets all along this line. So if you want a certain level of risk, you can create it. If you want a beta of 1.2 for your portfolio, you can create it. You can do risk-free borrowing and invest the proceeds into the market portfolio to put you here. So if there's an investment, so if you want that level of return, knowing that there's that level of risk, that's the combination that you should pursue. If there's a company that has stock that has a beta of 1.2, you can expect this rate of return. If there are no stocks with a beta of 1.2, you can create a portfolio with a beta 1.2 by combining, like I said, market portfolio with risk-free borrowing. Okay, I want to go back to that exercise and do a few things there and then finish this off. So the main thing below, in the slide below, it outlines that the CML just shows you the efficient portfolios, but the SML shows you any security and portfolio. So what I was just explaining was on that line are all the assets, individually even, and that exist. No assets in market clearing and in efficient markets exist off the line, and I'll teach you how to deal with or how to deal with assets that are off the line. So all securities are here, and securities can be duplicated, let's say it that way, by risk-free borrowing and investing in the market portfolio, the proceeds. Okay, so let's go back to that exercise. Let's finish that off, and I'll show you some risk-free borrowing example in that one. And then we'll do, all right, so what's the beta here? Okay. Efficient takes into consideration all available information. Okay, efficient pricing. There's a chapter, I can't remember which chapter it is, that talks about efficient markets. Read that chapter, Kyla. I mean, it's not long, short, or skim through it. Efficient markets. Okay, so that's where all information that's available is used to adequately price securities. You'll see, it'll make more sense when we get through these exercises, okay? You're asking great questions. Okay, so beta. What's the beta for this problem? Does anybody know what to do? So in a few words, what do I do? How do I solve that? Anyone? No, they're good questions, Carla. They're good questions, but you're going to get your answer soon, but it's good. I anticipate you'll get your answer. Okay, so how do I get beta? What do I do? In a few words or a few letters. That gives it away. Nobody? Use cap M. Okay, you guys doing it without me? So the expected return to a portfolio or any asset is equal to RF, right? Plus an adjustment of the market portfolio for every unit of systematic risk contributed by the asset. That's the beta. Beta, Y, and what's the market risk premium? What's the market risk premium that I put here? Just give me the number. It's easier if I just put the number in. What's the market risk premium from the information above? Right, 8%. So, that's it. So now you can find, you know the risk-free is 4%, you know this is 6, you can find the beta. There's another way to find beta, but I just wanted to show you the market. That's the that's using the CAPM. All this notation, try and read it, okay? Don't just see it as letters, notation, read it as concepts. So this is the formula. That's it. This is 8%. That's the beta of that asset that I already know. Okay, so what's beta Y? This one is 4% and this one is 6. Did we see that number before, 25%? Very good, so it's 25%. So using the CAPM, you're able to find that. But there's another way to find that, and when you combine risky assets with the risk-free, it's just the market return, right? Because the T-bills don't contribute any systematic risk. It's all just a portion of the market portfolio that creates systematic risk. So if you put 25% in the market portfolio into your portfolio, so if you put 25% of the risky assets into your portfolio, then it's just going to be 25% is your beta. I'm going to show you how to get that, not intuitively but mathematically. But first of all, intuitively, that's what you would do. It's just going to be that, because, okay, so I got to write this somewhere better, right? Use a different page. So what I have so far is the expected return on any asset is equal to the risk-free plus an adjustment by the market risk premium for every unit of beta. A fraction thereof. And also, so I just unraveled this to get the beta, but also the beta of a portfolio is equal to, oh, just let me add, so all I did was use that for Y, right? I just replaced that for Y. You can do it for any asset or any portfolio. Use the same relationship. The beta Y is also, or let's say it like this. Okay, the beta of a portfolio could be figured out by a weighted beta. It's okay, I'll just do it this way. So the in our case, it's the beta of F for the contribution of F, like so it's a weighted average. The beta is a weighted average, and this is all possible because we're making linear combinations. So I can make a linear combination of beta as well. But what happens to this? So this is a weighted beta. So if you combine two securities or assets as a linear combination, the beta is also going to be a linear combination of the two betas. So in our case, in this example, what happens is the beta of Y becomes equal to just the second component, but what's the beta of market always? So that's why it's XM. Okay, so you can put those formulas on this sheet so you have it handy. You can put it on your formula sheet, or let's leave it here. We'll have it here as well. So when you mix two assets, the beta will be the weighted beta, the weighted average of the two betas. When you mix the risk-free and the risky assets, it's the same thing, except it reduces to just the portion you've invested in the market portfolio, only systematic risk and the portion thereof. Okay, back to the exercise. Did you copy that? Like literally copy that? Write it down. So let's do the next one. We finished the first one. Let's do a shorted one. So let's do a borrowing against the market portfolio. Or in other words, risk-free borrowing. So how would you do this one? Oh, my microphone didn't turn on again. Sorry, I'm back. I'm back. I'm just waiting for you, really. I didn't say anything. Just like touching, trying to give you hints. So what do you do? I'm just like hinting. I didn't say much. I just started tapping and hinting. Okay, so where do you start with this? I guess you're looking at the solutions now. So we know that T-bills were shorted. $800 of T-bills were shorted. So this is going to be a borrowed amount. So it's not like a positive investment. It's not like these were positives, right? Because they were invested. Well, it should be a negative for cash flow, but regardless, these are positives. We see them as an investment. And then if you're shorting, it should be a negative. So for T-bills, you're going to use negative 800 out of 1600 invested, because you got to pay that back, right? So you see it as a negative. So when you sort that out, it's negative 50%. Now the weights have to add to 1. So how much in the market portfolio? You get it, Tanner? 1.5. Because, so that's the idea of borrowing against. I'm going to borrow this money by borrowing T-bills and selling them, and I'm going to put the proceeds towards the market portfolio. That's why I have more than 100% in the market portfolio. So, oh, did I do that wrong? It has to be 1, right? So it has to be, yeah, they add to 1. Good. Now you guys can do the rest. Keep going. So you can find the weighted beta, and you can find the portfolio return by the weighted average. So the weighted average in both cases will get you the answer. Very good. So now you learned. That's right. So for here, for mixing risk-free and risky, beta will always be, the beta of y will always be xm. Very good. So this will be 1.5. And then the expected return to y, the portfolio. All right, so you're going to take, for this one, it's going to be so notice I didn't say much about it, but you see how I use the E. I only use the E when it's not risk-free, right? Because there's no variation in risk-free. So this is, the E is just to say the mean. If you're not getting that, that's just the symbol for the mean, or the average, expected value. I didn't mention it You guys didn't complain, so that's all that is. So this is expected return to the market and XM. So when you put all that together, you get 16%. Everybody sees that? Maybe I'll leave some for you to figure out. So work through these questions and just keep in touch. I'll do my best to respond. But you have the answers, okay? Okay, back to the notes. So we were saying so all assets are on here, and you know what? You can even go back here as well. Me and my lines, I can't do it. I gotta learn how to use the line feature on here. Okay, there you go. So that line extends even there because you can have negative betas. Does anybody want to give me an example of a security with a negative beta? What's the beta again? Beta captures the sensitivity of an asset's returns to market changes or market returns. Changes in market returns. Sensitivity to changes in market returns. So what would have a negative beta? What would behave negatively with the market? Alan knows. So precious metals like gold, silver, platinum, when the market is down, okay, when the market performs poorly, when there's been market crashes, investors turn to alternatives, and so they take their money, whatever they can, out of their market investments, in corporations, and they put it into precious metals like gold, silver, platinum. And so you'll see in the last few months with COVID, gold shot up. Silver did too. Okay, so those are out here. Okay, so now, I didn't want to close that. I just wanted to save that. All right, so we have only a couple of pages left. So let's use the security market line for two assets now, not just because up here in the exercise that we did, we were just combining risk-free and the market portfolio to end up here, right? Or we could actually go all the way down here. But now I want to combine assets to end up on the security market line using the capital asset pricing model. So this is an example here. So here are two stock, A and B, and these are their betas. Use the capital asset pricing model to determine their required rate of return, the expected return for investors in those stock. In other words, we call it the cost of equity. So you set it up. Try speak it to yourself, you know, not just copying the formula, because it's really tedious when you copy formula. So the expected return to A would be a markup above the risk-free by the beta of A for every unit of beta, you're compensated the market portfolio. So I'll write it this time. No, I won't write it. Well, maybe I will write it. But what I really want to do is put the numbers in, right? Because that's not going to get you any points. So it's going to be, with the information of the risk-free is 4%. You can write it in percentage. You can write it in decimals. I'll do it in percentage. The beta is an index, right? 1.2. It's not a slope. It's a slope of a different, so again, it's not a slope for this, how do I explain that? It's a slope of market, of return to the security on market returns, but not a slope in the security market line. 1.2 times the market risk premium is 10%. I'm just going to jump to the chase there. What do you get? Oh, I mixed it up. You're right. Sorry, Alan. Kyla, you got me right. So yeah, sorry, I put the wrong number in there. Let me do that again. That's going to be 0.8 times a 10%. You can use decimals, you can use percent, you just have to remember which one you used. And then for B, it's going to be the same, except for I change the beta. Okay, so it gets very tedious, like I said, because these are all the same. It's just this changes. I'll put the number over here. See, everything's the same except for the beta. So what do you get for A? What do you get for B? So, yeah. So this A has to be, the beta is 0.8, so it has to be less than, right? It's going to be less than the market portfolio. The market portfolio is 14, not the market, yeah, the market portfolio is 14, so we're going to be 12. It's 12%. And this one, the 1.2, is larger than the market portfolio, so it's going to be larger than 14, and it turns out to be 16%. So everyone take a moment. To make sure they get that, and I'm going to go back and plot them. Now this is really messy, so probably won't plot here, but let me, so all, I told you all securities are here. All securities are here. So that means A and B should be here, right? So let's say A was 0.8, right? So it would be here. can't do a straight line for my life. Let's do that again. So this is 0.8, and so, oh, you can't, that's not a good drawing at all, because now it's too close. Do that again. I'm not trained on this iPad, as you can tell. I'm learning. So that's 0.8, and so because it's less than 1, the expected return will be less than the 14%. And the other one was 1.2. And you see that will be bigger than 8%. I mean, what did I say? That'll be bigger than 14%. Oh my goodness, doing terrible on this today. I don't know if, I guess my stylus is losing its mojo. All right, so you guys finished the calculations? Let's get on to the next part. The next part says, let's create a new portfolio combining 60% of A and 40% of B. So if $100,000 was invested, 600 would be in A and 400 in B. So from here you can figure out the expected return as a weighted average, 13.6. So remember, it has to be between, it's a combination between 12 and 16, so it's somewhere between. And similarly, the beta is a weighted average, so you'll get somewhere between 8 and 1.2, so it's 0.96. But you could also use the CAPM. If you had the beta, you can use the capital asset pricing model and you would get the same answer. Am I going too fast? So this is what we did on that slide before, but the two portfolios, the portfolio, sorry, was made up of risk-free assets and risky assets. But here it's A and B, they're just two assets. It's the same rules apply. You just get simplifications with the risk-free and the risky asset on that handout or in those exercises that we were doing. So A and B are going to be on the SML. Also, the portfolio will be on the SML. It'll lie between them. So you could plot that and you could see that they're all on the line. So, you know, if this is A and this is B, if you guys actually plotted all of this to scale, you would find P would be there's more of A in it, right? So it would be closer to A, but it would be between the two. So this would be portfolio P. I should make it a regular P, you'll get confused. And that's the SML. Okay, what I want to do now, it's 10 o'clock, I'm going to do the last handout I'm going to do, and then we're going to go. And so that means that I will not test you on the last set of notes, which is bad, because I'm not teaching WAC, which is bad. I really need to teach WAC. But I'm doing all these reviews to help you understand. Oh, I don't know. Well, the WAC doesn't take that long, really. What I could do is, I just don't want to, well, I guess it'll be on the final. So, what I could do, let me see. Let me see. It's really hard to judge how much time to spend on stuff with 5 weeks. Looking for excuses, I know. But let's see what I want to do. So these are the notes. So 4:15. Like, these are the remaining notes that you need to cover. I'm going to ask you, you're going to be studying for the test. Kyla, individual securities fall in the SML. I just showed you because A and B were there, right? A and B and the portfolio. All individual securities, all portfolios are on there. Okay, so these are the notes, the last set of notes that's supposed to be for this test, and this is just an application of the capital asset pricing model. But with this, I want to show you about WAC. No, I guess it's just going to be on the final. Portfolio theory eats up a lot of time. There's not a lot of notes here, it's just 10. Okay, let's see what I can do. Maybe I can fit it in. Let's get out of here. Okay, sorry, Ben. I'm going to go to that in a second. So what I want to do first is emphasize this handout 15. Ben, those are just the last set of notes for Module 5 that I really want to squeeze in. So I think I'll just stay overtime and you guys can go sleep and come and watch it later. What I want to show you, let me see. All right, this one, yeah, okay. This one, I'm just looking at my notes. So review 2, let's go to review 2. Go to review 2, which is called 513 or 514, 512. 512, yeah, 512. Okay, let's look at 512. 512. So here you go. We're assuming the capital asset pricing model holds and that the risk-free rate is 7%. The expected returns on the market portfolio, let me just underline that. The expected return on the market portfolio is 12%. Just be careful with some of these questions. It might give you the market portfolio and it might give you the risk premium, so be careful. This one is the market portfolio. Consider the following two capital asset portfolios that are out of equilibrium. So this is off the SML. That is, they do not fall on the security market line. So these do not fall on the line. Okay? So what you need to do is draw them, show the risk-return trade-off in the illustration with the security market line, the two portfolios, the risk-free security, and the market portfolio. And label your axis. Well, I already did it, but I could ask you on the test to label it, so don't forget to put those in. And don't forget this is 0, right? So I'm going to show you let's look at the key. I'm going to show you everything plotted and what I did, and you'll take time to read it over. And then I really want to get into the second part of the question. Let me show you the solutions. So this is a little bit, beyond what I've just taught you, a little beyond what I just explained about capital asset pricing model. Here's the nice drawing, because there's no way I'll be able to draw this so well in here. I really need training in using a stylus or the software. Okay, here it is. This is everything drawn for you. There's A, there's B, they're off the line. What I've done is I've marked the beta. So they told me the beta was 1.5, and that's a correct. We assume that's done properly. Hannah, it's module 5. Module 5 is on the exam. Okay? Because we did 1 and 2, then 3 and 4, and now we're just doing 5 because there's tons of stuff in module 5. So everything with a 5 on it could be on the exam. Okay, so I've plotted here because B, you were told B had an expected return of 12%, and that's the market portfolio's return, right? Oops. Okay, so they line up. So there is B and 1.5. So it's not hitting here. Now, how did I get this line? I got this line because I'm told the market portfolio is, I'm talking about this line. The market portfolio is 1 with 12%. So there's no way that B with 1.5 at 12% should be on the line, right? So we need to figure out first, what is this? What is it? What should it be? So to figure that out, how do we figure out what it should be? Does anybody know? All of these assets, portfolios, projects, all these investment opportunities are on the line. So that means if I use this beta with CAPM, I'll be able to find this value, okay? And when you do that, so I've done that below, this is the capital asset pricing model below for B. I calculate it using the 12%, the 7% risk-free, 1.5 is the beta, and the 7% risk-free, right? I get 14.5%. So that's the actual, that's what it should be. So what's going to happen? So these calculations down here are the beta, sorry, the return, expected return stars. I didn't put the stars down here. I guess I should put the stars on. There should be a star here. And then also an asterisk here. So for this one, it turns out that the security is out of equilibrium. It doesn't fall in security market line. So what is the process by which it would get back to the security market line? What's wrong here? Or what's right? For this level of risk, investors would require, according to the capital asset pricing model, this level of return. So investors currently invested in B will abandon B, and they'll, if for this level of risk, they'll do this, whatever this is. This is a combination of the market portfolio and risk-free borrowing, right? To get here, they'll do that, or they'll find some other security that is properly priced, or if in equilibrium. If this is their level of risk tolerance, they will achieve the required rate of return for themselves. So they'll get out of B. What happens when investors dump B, when they start selling off B? The price of B falls, right? Because people want to get rid of it, they offer it, they give it away for nothing. Now, how do we price securities, risky assets, stock? How do we price them? We usually take our formula, right? Is usually C1 over. Now I'm not going to write I anymore. Now I'm going to start writing E. E, expected return to the asset. Okay, so that's just more fancy because I'm able to calculate this. So as this goes down, the price starts falling, imagining that the dividend, expected dividend, stays the same. The expected return will simultaneously rise. And it'll rise to the point here. So what's happening here is that this security is overvalued. The price is too high. So stock or securities, or anyway, securities, investment opportunities, portfolios out of equilibrium will adjust through market clearing, for market forces will adjust. In this case, I've illustrated how it will adjust. So the price will drop as people abandon that asset. They sell it off, offering it at lower and lower prices to get rid of it, so that they can take the proceeds and invest in, if they really want to maintain this level of risk, invest in this, whatever this is, this security here, or some portfolio here, or some combination at least in the case that they can't find a suitable security, they combine the market portfolio with borrowed funds from, funds that they've raised, they finance through risk-free borrowing, T-bills. So securities under the security market line are known as overvalued. Now, when a security is overvalued, okay, I know I'm going to end soon. There's not going to be too much. I just want to finish this because this is a clincher. I don't know where you're going to get this from. I mean, it must be in the textbook, but maybe not so. So relevant, or as far as this example goes. I think you need it to be spelled out. So these are overvalued. The price was too high. The price needed to fall. What do you do with an overvalued security, or if you're aware of out of equilibrium opportunities? You know the price is falling. What should you do? I did mention this in the class today, but we were talking about T-bills at the time. When you know price is falling for a security, when you're aware, you should short sell. So if you don't own the security, but you're aware, you can make these calculations and you see B exists, you can borrow it if you can find someone, a broker who will get it for you. You can borrow it from the broker, and provided he doesn't have the information you have, you'll be able to borrow it and then return it to him at a later date, but then you would be returning it for a cheaper price. So in the meantime, you made an arbitrage profit. Very good. You guys are good. Okay, what about A? What's the situation with A over here? Also, A, you could figure out this A at 1.2, it should be 13%. It should be priced at 13%, or the expected return would be 13%. Now, investors in A, for this level of risk, they're getting this excess return. Investors aware of this will flock to A, offering higher and higher prices for A. The price of A will go up, provided the dividends stay the same. That means the expected return for A so as this goes up, to maintain this relationship, to maintain that dividend, the expected return will go down to maintain this equation. So the expected return goes down back to equilibrium. That's the adjustment process. That's the correction. These are currently undervalued. So securities above the security market line are undervalued. What should you do if you're aware that a security is undervalued as an investor, apart from if you have it or not? If a security that you find out there's an A floating around, investors, Kyla, from the investor perspective. So investors looking at A, so initially I'm talking about people holding A to discuss the investment. Then I'm talking about investors in general. So if a security is undervalued and you're aware of it, you should buy it. You should buy it and hold it. Okay, that's known as long. So it's the vernacular for buying and holding. Buy it and enjoy the ride as the price adjusts. So don't forget, prices and expected returns are inversely related, right? From our time value of money formula. Everybody's okay with this. This is a perpetuity. That's all this is. pricing stock. You see what you've learned is so useful. You can understand the theory, which I think some of you seem to be getting. So that's why we call it a capital asset pricing model. By getting the expected returns, essentially you're getting the price, because you use the expected return to value assets. So it's called the capital asset pricing model. So long means buy and hold and enjoy the ride. Okay, so it's 10:14. I can let you go, so I won't do much more, but that means, hold on, that means you guys got to work on this yourself. I need you to, because let me see these. So all this stuff is relevant up until 517, cost of equity, 17, 18, and 19. That's all that's left, right? I should let you read it yourselves. It's really easy. You know, I think I should have whack on the third test. Very basic whack on the first test, okay? I'm not going to do anything crazy. Basic whack on the third test, because you also need to do the you have to prepare the assignment questions. So I'm going to put it all on. I think you can read those notes and do very basic whack stuff. Don't worry about too much. I won't put too many questions. It's not going to kill you. You know what I'll do? I'll make some you have choice. Let's do questions if you want. Let's say that, because some people, they do know whack. It's not a big deal, but I'll have to spend 30 minutes. I'll try and spend just 30 minutes on it next week. So read it so you know it for the final. I'm not going to spend too much time on it anyway. Okay, so all that stuff is examinable, and I'll leave you with choice, and I'll have a whack question in there, at least one. Okay? Any more questions? I'll stay on, but other people who have to go, go ahead. Stay on 2 more minutes. I never mentioned this, but you guys can put the captions on the videos, or maybe I did, but you can put the captions on the videos and you can translate them. The translator's not that bad. I mean, I only use it for Spanish to English, but I find it's not that bad. So if any of you have English as your second language, you can use the captions and the translation to watch the videos. I'll write an email with those, with the thing I said about the test. The choice. Good night. Well, it's an investment. If I explain it to you well, then I can leave things in your hands, right? Good night. Okay, good night.